Hello and welcome. This is Barrett from the C4 Cyber Club here at Cypress College. In this video today, I'm going to cover the NDG Linux Essentials Lab 5, which covers command line skills. So as you can see with this introduction, we will learn how to use basic features of the shell, which include exploring bash features, using shell variables, and being able to make use of quoting and what's called globbing. Okay, so you'll see that on the right here, we have an interactive lab. If you're following along with your own Linux Essentials course through the Cisco NetAcad, and if your screen is just blank, a little tip, just press the enter key or click on it, press enter to kind of wake it up a little bit. I noticed that sometimes it might wait for some sort of response from you. And then you should be looking at the prompt here. And essentially that's the first thing we're going to talk about. So you notice that these labs do have a bit of text. I'm not going to go over everything here. I'll paraphrase some things a little bit, but I'm also going to add a bit more context and maybe show you some extra commands along the way in order to sort of build up your knowledge of these commands, because they're ones that you'll be coming up to in future modules as well. So hopefully you can kind of reinforce your learning along these videos as well. So the first thing we need to look at here, this sysadmin, the highlighting unfortunately in this terminal is not the best, but the sysadmin here is the user account. So the user is sysadmin, and this at localhost, the localhost is actually the computer name or the host name, you could say. And then you notice this tilde symbol. This is telling you the current directory, and that actually stands for the home directory. So if I used a command called ls for listing, this lists the files and folders of this directory. You may notice a test1. You probably won't see that straight away. That's something that I had created previously. But now let's say if I change directory into downloads, the cd command is for change directory, something else you'll come up to in future lesson. You'll notice now it's not just a tilde, but it has the /downloads because we're in the home folder and then the downloads folder within that. Now, if I did cd and then move to /, this actually takes us, you'll notice the tilde is gone. And if I do a listing of this directory, this actually took us to the root folder. So we see a lot of system related folders here, and we also see the home folder. Now you can also go back to that home folder just by typing in cd. You notice that the tilde is back. If we did a listing, we now see that home folder directories again. So I know that was a lot. That's actually much, like I said, that's much more than what's covered in this first page. But I really just wanted to show how this symbol changes as you move through different directories. So I'm going to type in the clear command, clear this screen. The other important thing to learn from this page is command line syntax. So when I typed in ls, this is a command. Now I can add an option to that to make it report something a little bit different. So I could do -l, to do what's called a long listing. Now you notice we still get the folders and files here, but we get a lot more information. And we'll go over this in just a little bit. And also you can, mostly every command is going to have a help option. So you could do --help. And this is very useful because this is going to show you all the different options that you have. So this is the help information for the ls command. This one's pretty handy, the -a. It's going to show you all entries that start with a dot. And within Linux, if a file begins with a dot or period, it's actually a hidden file. So I'm going to clear the screen. If I did ls-la, you can actually combine options. You'll notice that this shows us much more information, and it's showing us these hidden folders and hidden files. In the directory listing, if you see blue, blue is for folders, white is for files. And actually in the future, you may see a green executable file. So that means if it's green, it's something you can actually execute. And then finally, the arguments here. So remember, command is always necessary. Options and arguments are optional, and that's denoted by the brackets here. So you don't always have to add those, but they will change the results of the command. So remember, ls is a command. ls-l, that's adding an option to it. Now, an argument would be this kind of example. So if I did ls-l for a long listing, but I wanted to redirect that output into a text file called listing.txt. Now, when I press enter, you see it didn't give us the listing like we saw up here. But now if I do a listing, we see that listing.txt was created. And that's because of this command here. So I added an argument. I essentially argued with this command. I said, I know you normally want to display to the output, to the screen, but I'm arguing with you with this redirect symbol, and I want you to send your output into this text file. And now I could open up a text editor like Nano and look at that file, and you see that that gave us back. Essentially, this is the result of ls-l command. So that is an example of an argument. So this is largely how Linux is made up. This is the more you start to understand this, the more you can see the power in a lot of different commands depending on the options and the arguments that you give it to, just make it all do what you want given your situation. Okay, so we went over this. Although I will go into a little bit more detail about what this information is. So let me clear the screen. Handy tip, Control-L is another way of typing clear. You actually don't have to type out clear, just use the shortcut. So ls-l again. So remember, this is listing the folders and files. These two columns here, sysadmin, the first one relates to the user. So it's the user sysadmin, and this column here relates to groups. Now, by default, a new user is just automatically entered into its own group name. But let's say if you had a user named Bob and he was in the sales department, you might want to add him to a sales group, or somebody else might be in an HR group or a IT group, etc. This column here is the file size of these folders. You can see this file size of listing.txt is just 584 bytes. The date created. Now, over here, this is something we'll get into in a future module, and it relates to ownership and permissions of files and access. So it relates to who as a user has access to this folder, who as a group, and then all other users as well. So you could potentially allow only the owner or the user of this folder to access it. You may allow different types of access to a group, like read-write permissions, maybe not execute permissions. So the R is for read, W is for write, X is for execute. And when you see the D here, this is telling you that it's actually a directory, because you notice on the text file here, this dash is just blank. So we will get into more details about this, but just thought I would mention it now. All right, so let's keep moving on. Now, remember, we see the tilde here. We are in our home folder. But what if we want to get a listing of this temp folder? And this is actually a folder that's listed in the root directory. But we can just give, after the -L option on ls, we can add an argument and say, I don't want the contents of this current folder I'm in. I want to give you an absolute path of /tmp. And now you see it's going to show us that information here. But we still remain in the home folder. Okay, we can do who am I. This is just a very basic way to ask for your username, which is sysadmin. Uname is a good way to get information about the system. So by default, this is displaying the operating system. Let's go ahead and use that help command that we were talking about earlier. And you could see we can just get all information. We can get specific kernel name, node name, kernel release, kernel version, processor, all this different stuff. So we could display all of that by saying uname and the option -A, and you'll see that's all displayed out there. Okay, let me clear the screen. Whoops. Sometimes you have to like really click on this this terminal to make sure that your keyboard is actually focused on that. Okay. So pwd, I often want to call it present working directory, which technically is what it is, what it shows you, but it actually stands for print working directory. And you can see down here in this blue box here, old Unix systems actually didn't have monitors, and it literally did print this information out of a printer. But essentially what this is doing is showing you your current location on the file system. Okay, command history. This is very useful. So if I type in, actually first, you'll see I'm pressing the up arrow right now. It actually scrolls through or goes through all of the previous commands that we were running. So if I wanted to run ls again, I found that there, press enter, and it runs. And it's pulling it from this history list. So you can see a whole bunch of different commands here. And let's say if I wanted to run pwd again, and this comes in handy, especially when you get into running much longer commands through like scripting, and you're combining things, you're combining multiple arguments and multiple options. It may be such a long command, and you could just type in the exclamation point and then the number of the command, and you'll see it runs it again, and then it gives you the output. Let's see. Yeah, pretty much goes over exactly what I was just doing. We could also ask for a specific amount of history. So we could just say, just show me the last 5. Or I'm going to press up, bring that up, show me the last 10, right? Okay, here's the section where it's showing you how to pull a particular number. Okay, up and down arrows. Yep. You can access that through that. Okay, so that's, yeah, pretty much it with history. Pretty straightforward. Now we're going to move on to variables. So this first example of echoing, so the echo command essentially is used to print text out to the terminal or to the shell. So we're not working with a variable yet. We're just going to say echo hello student. You'll see that that echoes that out to the shell. Now we can also echo out variables. So whenever you see this $sign and then all caps, that's going to be a variable. And in this case, this is related to the size of our history. So we echoed out the hist size, and this is saying we are allowed up to 1,000 commands within our history. So once we reach 1001, it'll start overwriting. We can echo out path variable. Oops. And so what this path variable does, it shows you all of the locations where a lot of the various command files are located. And if they are not in one of these locations, you wouldn't be able to type it out at the command prompt wherever you're located. So ls, for example, not ks, ls, this is located in one of these folders as far as the file. And I believe, yeah, so the next command will actually show us, if I do which ls, it shows us the folder where it's located. So it's in the root folder, in the bin folder, short for binary, and then ls command. It's also asking us to do which date. You can see these are all located, all these commands that you can run are located mostly in this bin folder. And we can actually even access that, get a listing. And remember how I said an executable file is in green. So all of these, RM is for remove directory. There's our print working directory. There is that nano text editor that I used a little bit ago. ls right here. So yeah, a lot of the commands are located in this folder. I'm going to type cd, enter, to go back to the home folder. Go ahead and clear the screen. Yeah, so that is the which command. Okay, now we're going to move on to command types. So we could determine what type of a command we are working with. So type cd, which is for change directory. Remember, this is when I changed into the bin folder just a moment ago. But this is basically telling you this is a built-in shell command. So the bash shell just immediately knows what to do with this command. Let's do type, print working directory. That is also a built-in shell command. Now let's take a look at type ls. So ls is, there's an alias connected to this command. And essentially what this is doing is it's running the command ls, but it's auto adding an option. And it's auto adding this color option, which is why when you run ls, you see it in color mode. And you see, blue is a folder, green is an executable file, white is a standard file or text file. So if we type in alias, we can actually get a list of all the different aliases that exist on this system. So you can see there's some for ls. Remember we were talking about the -a option on ls, so which shows hidden files. So you can actually type, there's an alias built in here, or not built in, I should say. It's been programmed. We could just type in LA, and you'll notice that shows us files with this dot or period. And so those are actually hidden files. And I had actually put in an extra alias here where we could just type in hello, and it's going to echo back hello. So you see that there. So it's nice because you could really customize your own system. If there's a certain type of command where you prefer a specific type of options. So for example, let's say if I like to always run ls with -l, a for hidden files, and maybe h, which stands for human readable form, and that shows a much more detailed type of size listing, so 4.0k rather than displaying like 4096. I could program this as an alias to, you know, be whatever I wanted it to be instead of having to type that out. So you could see how aliasing definitely comes in handy. All right, let me clear the screen. Now we'll take a look at what is called an executable program. So V is another text editor. And so you can see here, this is located in the user folder bin, and then V is the executable program. All right, moving on to quoting. So there's 3 different types of quotes that are used in the bash shell: the single quotes, double quotes, and back quotes. So it's important to know the difference and how they're used. This section might be a little bit confusing, and you might start to think, well, like, in what context do I use this? And it really won't start to make sense until you get into more detailed scripting. But bear with me. Let's go through this, and hopefully it will start to make sense as you continue to work on learning Linux. So so we know that the date command prints out the current time and date. So if we wanted to maybe craft a script where at some point it echoes out today's date, you might think, okay, echo today is date. But what happens is it actually prints the word date. It's not printing the command. So that's where the back quotes come into play. So we need to use the back quotes, and remember the back quotes are next to the number 1 on the left side of most keyboards. So we put those in between, put date in between the back quotes, and now it echoes out today is, and then it pulls the actual command inside of there. Another way of doing this, because this can be kind of confusing, echo today is $ parentheses date inside, and then that's going to do the same thing. Like I said, this, I believe these days this is the preferred version just because it looks a little cleaner, and there's less confusion considering there's 3 different types of quotes that we work with in Linux. Okay, so this one's getting a little bit meta, but you know, think of a scenario where maybe you want to redisplay this learning session within a shell script and print it out on the terminal, and you actually want to print back quotes, date, back quote. So you can use the single quote to do that. This is the command. So single quote, back quote, date, back quote, single quote. So now you see it did not display the command itself, but it actually displayed the back quotes with date inside. So that is the use case for the single quotes. We could do something very similar with a backslash as well. So we use the backslash, next the back quote. So this is basically saying, I want to actually print this. I don't want to use it as a part of this, executing this command that I'm about to give, and then another backslash followed by the back quote. So essentially what comes after the backslash is important. And you can see that's the same thing as using these single quotes as well. All right, and now with double quotes, they actually don't have any effect at all on back quote characters. So if we did, this is the command, and then double quotes, back quote, date, back quote, double quote, you see that, like I just said, these double quotes have no effect, and the date command was ran. Now, where the double quotes are used, and we'll get into globbing in a future lab, but essentially this asterisk here, it's called a globbing character, spelled Globbing, globbing. If I did, remember we are in the home folder. Let me clear the screen. So we have these directories available. If I did echo D asterisk, it's going to echo out all of the folders in this directory that begin with D and end with whatever else comes after it. I could do the same with, echo P asterisk. There we go. And we see we get pictures in public. Now, let's say for some reason I want to actually echo out D asterisk onto the screen. This is where the double quotes would come into play. And there we can actually echo that out. And you can even see here in this little box, quoting may seem trivial and weird at the moment, but as you gain experience working in the command shell, you will discover that having a good understanding of how different quotes work is critical to using the shell. And that is very true. All right, so our last section is on control statements. And a lot of this kind of borrows from programming concepts and looking at Boolean logic like true and false, and or. We'll go through this. Okay. So a semicolon is can be used to separate commands. So let's say hello, echo hello, semicolon, echo Linux, echo student. So there's actually 3 commands in this one line. So these 2 commands are separated by the semicolon. You don't need a final semicolon on the last command. You'll see that it runs it, each command, one after another. Now we can add, the lab is using this false command, which technically executes, but because it's false, it doesn't return anything. And the thing with these semicolons, even if the first command is false, here, I should highlight, it will continue on and do the rest of the commands. So it will complete all of the commands. Now, if we look at the and command, it will appear to be pretty similar. So we could say echo start and echo going and echo gone. So once again, each command is executed here. But what happens when a command doesn't execute properly, or there's an error, or it's a false return? So say echo success and false and echo by. You see that it stopped here. Well, technically, no, it didn't stop there. It did run this, but because this was false, it did not continue going. Okay, now we can look at the double pipes, which stands for OR. It's an OR statement. So if we say false or double pipes, echo fail or, we see that the only output is the second portion, because it's basically saying do this or this. So because this one was false, it moved on to the next one, and this one was true because it was a correct command. It displayed that output. And now the next one, if we say true or echo nothing to see here, nothing is displayed because this first command is just true, doesn't necessarily display anything, but it reacted as true, so it didn't need to follow the OR into the next command. Great. So that is the end of this lab. This is definitely one of the longer labs in the Linux Essentials, but it's definitely a good one. So thank you very much for watching. I'll see you in the next one.